Okay, potential energy. Woohoo! So you know what kinetic energy is. We talked about kinetic energy. Potential energy is just stored energy. It's stored in one form or another, and you'll notice that I have two images on the slide. And I asked you this question in your what do you know? I said, are there different kinds of potential energy? And most of you, or are there different kinds of energy? And most of you said, well, there's potential and kinetic. The one that you have used mostly up to now when you've talked about potential energy is gravitational. This is the one you're familiar with. This is the rock or the bowling ball at the top of the hill, and that's it. Potential energy is dependent on the relative position of an object. And that's a perfect description, Gesundheit, of gravitational potential energy. It can also depend on the characteristics of the material. And for those of you heading forward into engineering, you will become familiar with constant after constant after constant, because all materials have constants of elasticity, they have constants of conductivity, they have constants all over the place. And it's the characteristics of the material itself. It's how well it springs back to its form when you bend it out of form. It's how well it conducts electricity, or what kind of thermal conduction capacity it has. So those are things that are dependent on the characteristics of the object. What do you think is the other form of potential energy?
Spring energy.
Okay, we call it elastic potential. But yes, it is basically the potential energy contained in springs. Okay. Whoa. PEG. So meet your new friend PEG. Gravitational potential energy, PE sub G. This is all about an object's position relative to something that attracts it gravitationally. And because we live on this giant rock, this really lovely little rock on which we can plant gardens, that's our typical gravitational source. That's what we're talking about. The Earth under us is so massive that the gravitational attraction of me to this desk is minuscule in comparison, and so we don't see it. If me and this desk were floating out in space together, and I don't know why we would be strongly attracted to one another as two bodies that have mass. But here, the Earth overwhelms all of those other attractive forces. So the gravitational source that we always talk about, because we're doing all our problems in Earth-based physics, is the Earth as our gravitational source. And it's real simple. It's mass, gravity, height, MGH. It's the mass of the object times the free fall acceleration, which is negative 9.81 meters per second squared, times the height above whatever surface we're referencing. That's a cautionary note, the way I phrase that. Whatever surface we're referencing. So, a couple things to be aware of. This gravity here, we're going to use 9.81 meters per second squared. It's not a negative because the energy that this thing has is positive. Okay, it's got positive energy. It can do positive work. If you drop a bowling ball onto another object, it will do work on it to the point of moving it, to the point of breaking it. When you drop something, it's capable of doing work. So all forms of energy have the same units as the work that they can do, because basically the joules contained there are the amount of work it can do. So it's the same units. We harness this, but not nearly enough. And if we have 3 minutes at the end, we'll talk about one of my pet peeves. Okay, this was that cautionary note. Height above some surface that we're using as a reference. That height is arbitrary. 0 is an arbitrary number. So if I'm going to drop an object here, and it's going to hit the desk when I drop it, how much potential energy does it have? Is the desk my 0? Is the floor my 0? Is the surface of the Earth on the first floor of this building my 0? It makes the most sense to set as your 0 the thing that's going to stop your object first. So if I'm dropping this paperclip and it's going to land on the desk surface, the desk is my most reasonable 0. it would be really stupid. I mean, I suppose you could do it, but it's kind of ridiculous to think that the surface of the Earth, we're on the second floor of a building. I've got, floors, beams, girders, etc., an entire other cement floor with all its understructure under this, and I think there may even be some sort of basement or something under here. I don't know what's under here. It'd be kind of crazy to use the surface of the Earth as my 0 point. I think the odds of this paperclip reaching the surface of the Earth are about 0. Ha ha ha! So that would be a stupid arbitrary 0. So that 0 that we set is purely based on where our object's going to stop. And again, you can think about this in these terms. If you dig a hole in the surface of the Earth, underneath where you're dropping an object, you've suddenly given the object more potential energy because it's got more space to fall. Okay? These are really simple. Okay, so we do have a sample problem. This is on page 179. And, oh yeah, there are slides. Hold on. All right. This is actually, okay, we've got like 3 minutes. We will pick up here tomorrow. And then we'll do the 5D practice tomorrow. And since we're stopping there, I'm going to give you my pet peeve. I want to plant this seed so that you're as irritated as I am. Because I can. How many of you have ever been to Berlin Reservoir? Or Guilford Lake? Or Highlandtown Reservoir? Or Leesville Lake? What do they all have in common? Other than their bodies of water and you can go fishing. That's the low-hanging fruit. It's off the table. They're all damned lakes. They're all human-created reservoirs. None of those are natural lakes. We put a dam on a stream or at the head of a basin, and we're retaining water. And humans have been retaining water for a long time. Little earthen dam lakes are a real common feature of this area. Great. Now, out west, and my best friend worked on a campaign to remove a dam. Out west, one of their primary sources of electricity is hydropower. How do you get hydropower? Water falling. You're harnessing the gravitational potential energy of water that is impounded. So, here's the river surface. You build a dam, and you have a lake surface up here. And this amount of fall is the amount of potential gravitational energy that every piece, every drop, every kilogram of water has. You harness that potential energy to move a turbine to make electric. Great. Very, it seems seemingly very environmentally friendly, very low impact. One of the big controversial issues, the reason this is a problem out west is because they've taken as a biologist, here's the other side of it. They've taken amazing river habitat and completely destroyed it and changed entire ecosystems, wiped out salmon habitat, wiped out other species, really radically altered ecosystems to harness electric. So the campaign my best friend worked on was the removal of an old hydropower dam that was no longer terribly efficient, and they had done a lot of analysis and decided it could be removed and you'd have amazing habitat restoration. It would have ripple effects. Okay, I would never, for an instant, support building new dams on rivers just to move electrons. But here's the pet peeve that I want you to live with. Every time we've already got a dam, why aren't we using that potential energy to move electrons? Why aren't we moving electrons using Berlin and Dearborn and Leesville and Guilford and Highlandtown and any of those? You can do microhydro on a pond and a ditch. Okay, go be irritated. Have a good day. See you tomorrow.